Hey, Coffee Compiler Club. Here today to talk about compilers and language and runtimes and type systems and anything else, and whether or not I get yet another spam call for another golden investment opportunity while I'm on the call. Um, I don't normally have a set agenda. I guess I don't today either. I have a thing I've been working on all week, and I'm trying to decide if I'm being stupid and I should just throw it away and back off or not. So. I was I'm hacking simple, looking at how to do types. I have a type system I like, and it's in there, and it's been working for quite a while, and it's all great. And I have a somewhat more robust version of the same thing in AA, but the more robust version is a lot more complicated, and I'm trying to keep the simple version simple. Um, and then I started down the path of, let's see if I pull a doc up here, path of adding methods to simple, which gets me to the point of well, I'm hitting cyclic types, and I always hit them, and they're very convenient if you get them to, oh no, to zoom, hit the share button. They're very convenient if you get them embedded in the core type system because it means you can basically ignore where things came from. Somewhere in the world, then I make a struct type here. This is my sample scanner app, but I don't care what you want to call it. U8, there's a buff. There's an index, and I'm going to parse out numbers and expressions and whatever things. It's a go advance a pointer through a buffer, pulling out a list of numbers, CSV parser, whatever. So somewhere in here, I've made a method here. Let's see, I have the first one that shows us actually peak or skip white space. Here, let's do skip white space is a function which takes itself, and I don't care how we do self syntax here,
Mm.
including the input set, and it's going to say, while x is less than buff length and buff of x is less than or equal to space. That's a weird looking quote, Google. X plus plus. So skip here just says skip white space. Skip white space. Um, and the when I parse and I parse a scan object, I don't have any fields yet, so I don't know what it looks like. So I get a blank type. So somewhere in the world, I start out life with I have a type for scan. I don't know where I want to put my types here for a second. Scan is a well, okay, so I have a pointer to a struct scan. I don't know what's a good type syntax. I have my print version, and I have no fields yet. So somewhere in the world, this is a pointer to a scan with undefined fields. That's what I get up at the start here. Up at the start of here. So do that. There it goes. Yes. So I don't know what scan has, and then I start rolling through this nested block, and I pick up an X and a buff. And then I pick up a skip white space, and he says, "Oh, I'm a function," and I take a scan object. So what's the type of dot here? Well, I start out the type of dot. This dot, let's see here. This dot here, it's a pointer to a scan with no fields because I don't know what my fields are yet. Oh, I know some. I know X and buff, but not if I put X and buff at the bottom. So just move them down here. Okay. I don't know what the scan object has. Then I'm going to run through and I have to, do some sort of delaying action here where I see X is a scan X field, but I don't have any fields yet, so maybe that's okay. And you roll on. But when I run through the type system and I eventually close, I then get that scan it has an X and a buff. So I end with a pointer to a scan with an X and a buff. And I move the skip off to the side here, but we can put it in. I don't really care. has a skip white space field that I'm going to hide off to the side because it's a final constant that's been built in the constructor, so it doesn't need to be in every instance. And that makes it a method. So suddenly you have a class and a method. All right, so while I'm building things and parsing and doing whatever, the normal situation is I have strong types for everything always. I'm collecting types. And so somewhere in the world, I have a pointer to a scan that has no fields. And later I have a pointer to a scan that has a bunch of fields.
Mhm.
And the other thing I'm doing is that I'm interning all my types. And this has worked fabulously well for C2. And it actually works well with AA once you handle cyclic types. Because I get up here is that skip. What is the type of skip? So here is a scan object, but it has some types for these fields. X is a type int. Let's do it this way. Both is a type U8 array, which I guess I was doing. Yeah, U8 array, fine. What's the type of skip? Well, it's a function that takes a scan. It takes a pointer to a scan and returns me a void, zero, anything, I don't care. That's its type. Okay. So the type of scan is a collection of fields, one of which has a function which has a pointer to a scan. So it's a cyclic type in
Mhm.
that sense.
Mhm.
So when I go to the concrete implementation of these type objects, they're literally little objects you write in C or Java, except I'm going to intern them so I get some really nice. The intern hit table gets like a 99.9% hit rate. It's like a huge hit rate. So it just makes allocating type objects basically free. It's all cache hits to allocate a type object and then hit and find the duplicate in the table and then just, free up the one you just made for the next go round and then never leaves L1 cache. It's very convenient here. But if I look at this thing as I'm going to use some Java types to implement simple types, right? So I have a TMP, a type mem pointer in Java, which is a Java object which has some fields, one of which is the type struct field called obj, and it has some other things, alias and null or not null, has a nullable,
Mhm.
whatever, has a few other things in there. And
Why
then,
don't
go
why don't
ahead.
we have a pointer to the first field, a whole placeholder for a pointer to a first field in that temp, for example?
When I make a type mem pointer
Mhm.
to an unknown object like scan, I'm going to put the placeholder in the type struct. But you
Mhm.
could argue a different, different story here. So type struct, let's go, this is actually type struct. This is Java type struct. Type mem pointer. Fine. So what's a type struct? Well, he has some constant immediate things like a name. In this case, the name is scan. It's a string.
Mhm.
And actually, I make this, this is a final string name scan, blah, blah, blah. And he has an array of fields.
Mhm.
And he has some other stuff. Not too many other fields. There's like one other field maybe. What's a field? Well, this is just a way to, this is another Java type here. It has a field name. And in my case, the field name here is, skip white space, for instance,
Mhm.
and
But
has a type.
the key thing here is that the field stands on its own. It's not bound by the type struct. It doesn't need to be. It,
I,
it's a thing on its own. So it's not my next comment would be it's not like a method ref which is actually bound by to have a enclosing class. It's to have its owner as a
oh
to
yeah,
be.
that's not bound, right? So these are the implementation types as Java,
Mhm.
and so they are, in a sense, they're all flat. They're unrelated to simple types
Yeah,
directly.
yeah, yeah.
Yeah.
That was the word unrelated. Yes.
Okay. The type for the field here in this particular field is a type fun pointer, which will have things here, and so type fun pointer is a, let's see here, it's a collection of args. I actually have a type tuple type, but args and return and some other stuff here. Function index, which is just a bit a unique ID, whatever. So
Mhm,
people with the same
mhm,
signature, I can tell them apart. There's no naming on functions. All functions are anonymous.
mhm,
Um, and then in this particular case, the args array has an arg here, which takes a TMP to a scan, right?
mhm,
Oh, pointer scan. It's a TMP object.
mhm,
So maybe I'll quote it. I don't know what you want me to say here. This is of type TMP or type mem pointer to the scan object. So there's my cycle in that
mhm,
the instance from here has a pointer to the struct object, which has some fields, which points to a TFP, which point to args,
mhm.
which points to this guy.
The first
So,
argument, this guy. Yeah.
okay. So the couple things come out here. Without cycles, if I have no cycles and I want to intern things, it suffices to do structural recursion on all the subpieces because it always bottoms, with no cycles, it always bottoms out. As soon as
Mhm,
you bottom out, you hash, you look on the table, you get a hit or you don't, you
mhm,
install as needed. Now you have an object which is interned. There's only one instance of it everywhere, anywhere. Um, and then you go up to the next layer who then says, I do all my children this way. And then I look at my children's hash and I compute my hash in that and I intern myself and you build your stack of types up. In
mhm,
the absence of cycles, this works great. It's actually quite easy to read code because it's all just plain old structural recursion. For all my children, intern them. Generally speaking, they've already been interned upon construction. So when I make a new type, it's generally here's a pile of children. They've all been interned. They're all unique already. Do whatever hashing you do with them plus your constant bits and look up in the hash table. If you get a hit, take the thing I just constructed and throw it on the free list. You'll visit it, you'll use it again some other time. Otherwise, you're in the hash table and now you're in turn. So fine.
mhm.
So I have this nice, good, quick, efficient thing. Soon as I have cyclic types, you can't ask for somebody to be interned without interning their children. With by interning your children first, because of course you wrap on yourself. You
Mhm.
can't compute your hash as the hash of your children plus your unique bits.
Right.
Um, well, here's Kirk. So not a common visitor. Now I can't find him on my list. I'll deal later. Hey Kirk, we're knee deep in type graph theory things.
Lovely.
Um,
What language is this?
uh, the code at the top of the screen is simple code. The code here is a abbreviated version of Java, which is doing the type implementation of the simples types. So I'll just recap because maybe it helps to understand what's going on. I'm parsing some struct in simple, it's like a Java class. I'm parsing a Java class, maybe, not quite. And it's called scan. I'm making a scanner. Here is a skip white space. I might have a peak numbers or parse a number or parse this or that. When I parse this, I get a pointer to a scan object to begin with as a type, but I don't know what fields are in the scan object because I haven't parsed it yet. So I live with having a pointer to a scan object that has no fields. So the dot 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 in the middle here says, I don't know what fields go in scan objects. Then I go ahead and parse, and I parse skip white space variable value, which turns out to be a function. And I have a parse for an index and a parse for an array of characters. And the function has a dot here, which was it's not final syntax by any means, but it means this object. I'm making a method. So what is the type of the this object? Well, it's the type of a scan, except I don't know what the fields are yet. So then I have to go parse this guy. Now, all that's just you deal with parsing, and I'm trying to I have an implementation of the type system which I've been using all along and works really well up until you get cyclic types. Okay, wait a second. Where is it? What is a cyclic type and where does that come from? So once I get to the end of the struct scan, the parser says, well, now I know the fields for scan, so I'll go ahead and update. And there's an int field for the index pointer. There's a car array pointer. There is a pointer to a function, which, because it's a constant and a constant value declared in the constructor, I'll move it off to the side. It becomes a method oop in a class object at some later date. But the moment you can just think of it as it's part of the type for a scan object. So scan objects have a skip white space field whose type is a function taking a scan object and returning null, whatever. I don't care. So now, ignoring what this is sort of really, what you're trying to type here, how do I represent these types? And the type representation at the Java level, so below the / dash line, is all Java now. I have a memory pointer pointing to an object. He's got a type struct and some other constant bits like whether the pointer is nullable or not. The struct object says, I know the name of the struct or the class. It's a scan object. It has some fields, has a few other stuff. What's a field? A field is a field name and a type for the field and something like whether it's final or not, and some aliasing info, and a couple other constant bits. So in this case, I'm talking about the skip whitespace field whose contents is a function pointer, TFP, function pointer. What's a function pointer? I'm diving down to almost hit the wrap here. Well, it's a collection of arguments, it's types, it's a return type, it's some other constant bits. In this case, what is the arguments? Well, the arguments is a pointer to a scan object. So at the Java level, the implementation of the types, I have a cycle. I have a Java pointer TMP object pointing to a struct who points to some fields, who points to a field, who points to a function pointer, who points to a scan object, which which is Java TMP object. So up until now, I've been interning all my types, which works great with structural recursion as a very obvious, very easy thing. For all my children, intern them, compute their hashes plus my constant bits, now hash and intern me. As soon as you have cycles, you can't do that. So, I've been wrestling with where to go with this guy. And the version I have of this in AA is somewhat more robust and more complicated. I was trying to get a simpler version. One of the things that makes it simpler in simple is I guaranteed have a name on my structs. The struct is a scan object. It's a scan object. And in AA, all structs are anonymous as well. And so you can make replicant versions of the same struct and they should be considered the same thing. Can't do that in simple. Therefore, if your name is not scanned, you're not the same kind of a struct. You're a different thing. So in the lists of things that go into the interning types, everybody who has interesting type variations on scan objects come up with different types typically, and so they land in the as a unique new type. And when you look at C2, when he does types on Java, imported Java bytecodes, he'll have a fixed set of like 100 types that are like all the things the parser doesn't want to have to think about, that he just knows. You have a type for 0, type for 1. You have a type for the control is true or you're unreachable. You have a type for you're the state of some memory or not, or whatever. You have a bunch of these. Fine. But then you get more types because I just loaded a scan class, and the scan class has a character array. So I pulled up the character array class, which is probably already there. And I pulled up these other classes as you discover them. And also as you find immediate values, like restrictions on the range of values, like X is never 0 or never negative. And you discover that X is never negative as part of the optimizer. So you have a variation of a scan object where instead of an int X, you have a U32X. And you precision sharpen your types as you go. And so, for instance, here I might say something like I have a scan S, which I make from the new scan, who comes with a string ABC, and I'm going to parse my ABC string. Well, I make a scan object in the parser, but the typing system says, you made a new guy, he has constant buffer. I'll make a new scan type with a constant buffer. And you'll get a few hundreds of these. And in a big C2 compile, you'll get a few thousands of them. But the hit rate on the type interning table is like 99.9%. It's ludicrously high. So you just make types sort of freely, cheaply. You pull an object off the free list, you populate it with its fields. All the child fields have been interned already. So you just do a bunch of stores into a blank object. You look in the hash table, 99.9% of the time you get a hit. You return the one you got, and you put the thing you just populated back on the free list. If you later, if you miss in the table, then you leave the object in and you go make a new blank for your next attempt, whatever. And it's all L1 cache hits at huge hit rate. So it's a very cheap way to make types. And of course, in a compiler, you make these types all the time. This is one of the most frequent operations that go on in anyone's optimizing compiler is doing some of the types. I have some things, I want to do an optimization on them. The first thing I ask is, what are the inputs to this guy and what does he produce as an output? Those are all types. And if I change my types on input, well, I change my type on output. So you get a bajillion type construction attempts. Fine. So I've been doing this without cyclic types, with structural recursion, throwing types in and out of hash tables, all great. Now that I have cyclic types, I have to deal. And I'm trying to decide, and I have some success and some failures, and I'm trying to decide if I should not bother. And you know, the great not bother is to say, well, okay, so sorry. So the first fail mode here is I have a blank type in the hash table, and I have a filled-in version of the type in the hash table. And the blank type and the filled-in version coulda, woulda, shoulda look exactly alike and be the same type. And I'm forcing it, and then I have other issues because I don't have a good hash function, and then I'm screwed on what it means to be equivalent. So I can right now find equivalents in cycles during construction. So the obvious one is I make I got a feed function. I'm merging two variations of pointer scans, or linked lists is a better one. Two variations of linked lists, one that came around the back edge of the loop that I'm walking a linked list, and one that's the fall-in one that hands you the initial linked list. They're different pointers. It's a linked list head, and I'm walking the list. Are all of those linked list objects the same? Are they all final or not final, or mutable or not? If I handed you a mutable linked list and you walked until you found a magic element and then you modified and said, now it's immutable, and I'll just walk the rest of the list immutably, knowing that it's going to be, you know, asserting or something. I don't care. I'm just going to read only or something. That changes your types. And then, you know, the type system's like, here at the feed function, I'm merging a linked list mutable and a linked list immutable, and they're cyclic. And I produce an immutable thing because if you take an immutable and a mutable and you merge them together, you get an immutable. Um, is this immutable thing I just constructed equal to some prior immutable thing I have already in my hash table? The answer is yes. Go find it by doing a hash and then a lookup and an equivalence check, just a hash table. Except you can't hash a cycle, and
Yeah.
you can't do an equivalence
So
check with recursive descent on a cycle.
so how do you hash a cyclic structure?
Why not?
So in AA, I did a robust thing where I once walked the cycle, just collecting things that are members of the cycle as the actual tight circle, and get a hash here, and then everything whose unique constants that come off to the side or other objects would be little edges out of the cycle, and they all would take the cycle hash as a thing plus their own special hash zoring effect on the cycle hash. So that's kind of a complicated mess. It does mean that if I construct a cycle and I rotate it, I have a loop and I spin the loop randomly because I don't know where I started and where I'm going to end on it. And I compute a hash for the cycle. It'll be the same as every other cycle who looks identical to this cycle. And then I hit the same hash. If you don't have the same hash, you can't even get to the equals check because you miss in the hash table for the wrong hash. In the case of simple, I cut the cycle when I compute the hash by claiming that structs don't take the hash of their child fields. And that's kind of an ugly thing because it means that all scan objects all have the same hash. And then I have to walk the equivalence check for all variations of scans that I might make. I currently actually have it depending on the name of the fields and the alias info, except that if you're intended to be the same class object, like you're a scanner object, you will only have the same fields. You will only have an X and a buff field. So also hashing on fields that are all identical doesn't change the hash any and doesn't help the hash table at all. So I'm probably going to back that off and just say, well, you're a scan, that's unique enough. Now I have a bajillion, okay, 10, 20 scan things. I have to go walk them each one at a time and ask the equivalence check. And then the equivalence check does a cyclic equivalency. Um, if you do things with graph objects because you're a compiler, you know how to do cycle checks are two cycles equivalent? The general, so let's just be clear here. There's a general theory that says two arbitrary graphs to be cared for equivalency is NP complete, but we don't have two general graphs. Our edges are labeled by the field names. Because you have labeled edges, you don't hit the general case. So under the more specific case of labeled fields edges, the edges are labeled with field names. There's an obvious one-time linear pass, but you have to know when you cycle. So I have two cycles, and they both say I'm a scan. I have a skip white space field who has a function pointer to some args who have a pointer to a scan. So that's my cycle. I'm trying to say these cycles are equivalent. And what I do is I say, uh, take these two guys that are the scan objects, starting at the structs with the scan name, throw them in a visit table. That's a hash table of the scan objects. And then walk this guy, and he has to match this guy when he walks. So they walk in tandem, recursive descent, except when they hit another struct. Then you do the lookup and you say, well, we're both scans. Look in the visit table. Have I visited this before? If I have, I'm going to claim victory and say, okay, they are equivalent, and I don't need to go recursive again.
That is why we have a different versions of a scan during parsing. Is that correct?
I have two versions of scan during parse because one happens before I finish the scan parse,
Mhm. Okay.
and one happens after I
So
finish the scan parse.
I don't know. Maybe I'm speaking what I think here. So the problem is stems from here because
Yeah,
it's
yeah,
not finished. So
yeah.
why can we replace something like self, um, which would be a node in the graph? But that self is kind of unitary object. You know that would be the enclosing class. So you walk it after the fact. With this in mind, I think you can compute the hash because
Okay.
that would cause problems.
Well, okay. There's a couple things going on here. One
Okay.
is that when I have a scan object with no fields,
Mhm.
I'm kind of treating it like yourself here.
Yes,
I know it has no fields, therefore it is the scan that will show up.
but that would allow you to compute the hash because it will like a zero. It won't it won't change the hash
Yeah,
because it will change
exactly.
the
That's what I
okay.
have right now.
Okay.
A
Okay.
scan object with no fields doesn't do a hash on the fields.
Hmm.
If I later add the fields, I cannot change the hash. So
Because
I
it
have to
will.
have that same scan object, the concrete instance of the Java type
Mm.
mem pointer to a type struct I've made. His hash depends on the name scan alone, not
Mhm.
on the contents of the field types, because there are no field types yet.
Mhm. Yeah.
So it's fine. He is. He's a unique version of a scan object. He's the scan object that I made at the start of the world. That's yourself. I'm
Yeah.
claiming it's very, very similar to what you said.
Yeah.
So,
Yeah. Yes. Yes. I believe it is. Yeah.
okay. So then we get to I have a pointer to a scan object that's a self scan. The type mem pointer, the concrete Java object who I want to intern, takes his hash code from the hash of his child and some constant bits, the Boolean nullable there. Yeah, nullable Boolean. Right. Well, the type struct has this wimpy hash, a hash that only depends on the name scan. So the TMP that comes out of that is this funny TMP hash. And when I am, but it's okay, we're still fine here. And this will be true sort of in general, because I have no fields, I don't have any cycles yet for the scan object.
Mm.
And everyone who gets made during the course of parsing gets this pointer to eventually this hash, this wimpy hash from the scan object, from the blank scan object. Fine.
Mm.
I add the fields to the scan object, and I leave a flag in there saying you must only use the wimpy hash because you're a wimpy hash dude. All right,
Mm.
fine. So no one's hash changes when I finally get the fields put in. Then I come along and I start doing, so scan doesn't show this, but linked list with loops has this in spades. I get new versions. I'm trying to construct a new version of a type that turns out to be exactly equal to the old version with the wimpy hash. But the new version doesn't start life saying, I have a wimpy hash. So he wants to make a fancy hash based on the hash of all his children. And then his hashes are different, and he will never be equivalent to
Mm.
the declared hash that you get out of the guy who was
But
happened to
I will
be constructing the parser.
I will claim that hashing on a linked list is kind of different of finding it on the
Anyone
list.
with cycles, so like
Yeah,
trees.
but here the cycles is only one, but in the linked list you have to consider depth or something else in order to accommodate that.
So instead of a linked list, call it a tree with a binary tree, a left and a right
Mhm.
child.
Mhm.
And the same kind of thing. I have cyclic field references that
Yes,
turns into
yeah.
cycles in the
Okay.
type system, which
Mm.
has to be sorted out as a
Mm.
do I hash, do I sub? So let me stop here for a second and say that there's another version of solving this.
Mm.
I guess there's two other versions I could go to solve this. One is to say at the time that I get to the bottom of my scan and I complete it and I know what the type is and I have all the fields, go visit every partially constructed type that was based on a WIMP field or lack of fields and rehash them with full field strength.
That was kind of the self I was going maybe
Yeah,
do
right.
ahead.
So,
Yeah.
so
Yeah.
the problem I have here is I don't currently have any backwards edges. Like, find everybody who points to self. It's not from self, follow self's output edges to find all these types. It's
But
the other way around.
self, yeah. Mm. Mm.
Find everyone who
Mm.
points to self, which is what I
Yeah.
would have to do. So this would be sweep for instance, the interning table for instances of objects that have pointers to a self. And I
Mm.
could do that.
Yeah. Yeah.
And that would get rid of the problem as soon as the scan parse ends.
Yeah.
And then I'm left wondering what will happen. Will this scale up to like modules where I have unknown types that come from external modules? But maybe it does. Maybe that's a red herring. So
Mm.
I'll skip that. And the other
Mm.
the other guy to do here, the other method is to say um, everybody who has a pointer to a scan object can't have uniquely specialized scan objects. They're all folded together. Like I'll just take the string scan and do a lookup in a string to hash table, string to type table, and get you the same scan object based on the word scan. And that means that I don't get any typing
Specific.
specialization.
Yeah. You cannot specialize.
No constant propagation here,
Mm. 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 Mm.
which is kind of suck.
Mhm.
I'm pulling up scan, but you can imagine every other scenario where you have struct objects that have some self-referential properties. And then also, you know that you set the some flag to false. You know that some field is always left uninitialized. It's always zero. Um, it could be something fancy. So the declared type is pointer to a swing GUI state, but the actual compile optimized version is always null. You know it's null, and you would love to just throw away all the swing GUI hooks because it can't be called. Um, but that one, that one's like give it up at cycles by instead of having a pointer. Right now, I have all these nice little pointers. So I just say, oh, I'm doing a load. I'm giving a pointer to a scan. Well, when I do a load, I get a scan struct, and then I get the field from the load, and I go pull the field type out. Oh, what's the type of the load from a field? It's exactly this type. And I get all the precision of constant propagation by simply saying, follow the type objects directly. And you can go look at the simple code. These are all like one line, half a line. Hey, here's how you compute type for this. It's just, oh, got a pointer? Got a struct, get the field out of struct, get the type, done. And 1, 2, 3, 4, it fits on a line. It's easy.
Mm.
Um, this one would say, oh, got a pointer, got a struct name. It's a string. Go look it up in the table. And that's your closing your cycle is everybody goes back to the table, gets the same scan object. Okay. Now you've forgotten no optimization. You've forgotten everything. Or it's been, I say forgotten. What I mean is approximated. Everything's been approximated into the one scan
Mm.
object. And so, in particular, if you have a scan object that's not escaped, you make a new guy and you stuff things in it, and then you pull things out of it, you lose that. I mean, that's an obvious optimization point, and you would like lose it here.
But then again, on the flip side, we want specialized versions of scan, which will have a different place in the
Yeah,
table.
same for every other struct on the planet. So I don't like that version. The go hunt the all down irks my soul. Like go find in the interning table, go find all things that point to scans and update them. Hurts my soul because it's asymptotically bad performance. And surely there's a more graceful way to do this. And I've
Mm.
been fighting with the more graceful way all week. And I keep thinking I'm closing in, and then I back off. If I look at what I did in AA, I fought this problem for a long time, and I sorted out in the end by demanding that you indicate when you're starting to construct a cyclic type. And there are only a handful of places where you actually construct a cyclic type, as opposed to append a new thing onto an existing cyclic type. Um, and then as soon as you declare the start and the end, I can do the job here without having this. I have an unknown thing in the middle.
So what do you mean the start of the end? So we do know, so once we reach here, we do know that this is the end, the start and end of the cyclic type scan. So you can figure that out,
Right, right.
definitely.
Why do I care? Well, I end up with pointers to the middle thing. So the AA version of of a struct says, I wonder if this is the same thing now. Says that all un oh, I see. It's because the Henley Miller is being used to save me there. All
We don't
unknown.
have types. Here you have to at least to me it sounds that in order to compute the scan you cannot just take the name and you have a type. In order to make the scan unique, you have to include the type, which if you include all the names, then you can finish here. Since you have all the names, then you can
Well,
have
I
a
don't get
hash
all
of
the
the.
names till I'm done parsing, till you get down
Yeah,
to
so
kind of here.
so some amount of waiting should have has to happen either way.
Yeah, so there's another version of this which says waste, and that one is obnoxious because I can't. The way that parser is currently structured, when I build IR here, I give it strong types. So I can't build IR without having a scan object in hand.
In essence, this smells like, sounds like we should delay the finding the
Yeah,
the cyclic
there
types, the find the types until we reach the end of the struct definition.
so there is a version which says build an AST, get to the end of the scan object,
Mm.
construct the good type,
Mm.
then go parse the AST again to build SSA. And that's
Mm.
the other thing I'm trying to dodge.
Mm.
So let me finish
So
my
why do
thought
we need the
here.
AST? Why do we need the AST?
Because
So
you can't apply type. I don't want to build SSA graph
Mhm.
without having the types involved because I use the types to actually build the graph.
So actually, yeah, because the every type is part of the node object. So you cannot say you cannot put can you put nodes just for the sake of the type resolution? So can
Well,
you
that's what I just said is I look at the type to decide what node to put down. And now we could argue that I could go back around and saying I don't need to do that somehow. Like where I'm using the types for this. Uh,
usually I think usually in the compiler lingo the type would be var, and once it's discovered it will just update its field.
yeah, okay. So I don't have a var here.
Hmm.
At the moment, actually, I don't have the syntax. I literally have a scan here.
Yeah, so sure, that's fine. So yeah.
And except I don't have a type for scan.
Hmm.
So what I've done before, this is AA, is to say that there's a version of scan objects where they have all possible fields all at type, I want to say bottom, either type top or type bottom.
Hmm.
And then as you come along and add fields. You didn't really add them. They were just no longer the default all bottom. They're
Yeah,
actually
you
lifted.
specialize them.
Yeah, I
You
specialize
specialize them.
them. Oh,
Mm.
I have every possible field name, all infinitely many field names. But now
Mm.
the X field version has an int, and all the other fields are infinitely many possibilities. And then there's a buff, there's a car array, and then there's a
And
skip, which is some function pointer, and so on.
as a side effect, you have infinitely many bottom fields as a
Yeah,
side
right,
effect.
right.
Yeah.
And then when I close the scan object, I say the bottom fields go to top, which says they're undefined now and not they'll never be anything interesting. They'll always be the undefined value.
So can we do this trick
And
here?
then that means that the scan objects in the middle there pick up fields. So I have them right now as this, I have no fields at all. Oops, that's the dot dot dot. Oh, I can't highlight the dot dot dot. Have no
Mhm.
fields at all. And instead it would be, oh, I found an X field on the scan object. Well, I have to know that it's an int. So I need to shove an X into the scan object. So I get a new scan object that's the same as the old one, except of the infinitely possible fields, the X version is an int.
Hmm.
And you get all these variations of scan objects with different fields of different things, except that they're all compatible. And as they begin to get unified in the program, when someone says, make me a new scan and call skip on it or whatever, you fold them together because they'll be the type of this scan object has an X and type of this one has a buff, but I'm using them in the same place. So when I do a phi function merge, they'll they'll happily pick up both an X and a buff. So it makes a more complicated in-between state. You get these halvesies all the time. The other piece of that one is that the cyclic equivalency check.
But that would only work where because you can get a different versions of scan in their fields, but that would work because you are kind of unifying them after the fact.
Yeah, I'm trying to
Okay.
unify them without bringing Henley Milner in, but
Yeah,
maybe
yeah,
I
yeah.
can here.
So
That's
what
a
would be the solution? Maybe locally. So that was my next hunch. Locally, delay
yeah,
type it treat it like a Hindley Milner, but only inside the class.
yeah, you right.
These types here, the
As
types
soon as you
inside it.
say that, I want to. The obvious defeat is to throw out I have nested classes. I
Mm.
have Java inner classes.
Okay.
It's not necessarily a defeat, but if you're going to say, "Hey, do this Henley Milner inside this region," okay, I'm going to nest you.
Hmm.
And,
Hmm.
does that real still apply? And I don't think you need Henley. I don't think we need Henley Milner in your hair
So
because your scan has the word scan in it. That is the scan object. You can't be any other thing. I'm not allowing you to have unrelated scan names. It's like
yeah.
you know, if two different libraries use the word scan, they'll get name mangled by the library prefix, so they won't overlap or anything. They'll
Hmm.
not. You won't have that problem. Which means if your scan object or scan object in your fields are better, each variation that I found had to all be simultaneously correct. And then there's a simple unification that's not the full-on Henry Milner. That's just this guy has an X and this guy has a buff and this guy has a skip white space. Well, they're all at the same time true. And if this guy has an X and his value is pi, and this guy has an X and his value is 3, then I'm going to claim type error. Your X's are confused. So they would be compatible. Maybe that's the answer. Really?
Hmm.
That would be too
Hmm.
easy. That would
Hmm.
be I can keep adding fields. Oh, I see. Now the funny thing is but it's not funny. I keep adding scan objects into the hashing and equivalency checking with different counts of fields.
Yeah, the count should distinguish here. Why not?
Right, right. But it's fine. They would just say as soon as you get the cyclic version, but I would still do the cyclic hash the way I'm doing it now.
Hmm.
One of them is to chop it off and don't have a cycle in the hash, and the other is to
Yeah.
go ahead and find the cycle during the hash code computation, and then give everyone else and there is a head of this kind of a thing here. There is a head of the cycle. It's one of the structs that has a name. I don't care which one is the head of the cycle. So I said scan here, but you can have I have an A class that points to B, points to C, points to A, and then ABC or BCA or CAB are all equivalent. Can't tell them apart, but you can make a cycle hash that works pretty readily there still. You just have to deal with cycles in the hash.
So
Yeah,
how to
yeah,
deal?
yeah.
Which part? Which which way to take for the cycle computing hashing?
You have a hash that is computed irrespective, the order independent of whether you visit ABC or BCA or CAB, and that's XOR works fine.
Mhm. Mhm.
I add works fine. Multiply any of the commutative operations work fine. Um, but it does mean you have to build a set of things without interning any of them because you don't know yet. Decide that you're done building them
Mhm.
and then walk them all, discover the hash, the cycle, discover the cycle, do a cyclic hash. Now you can start doing interning things on the pieces parts. It's definitely a more complicated job. I was trying to dodge that. Um,
Mhm.
maybe
Mhm.
why? Oh, okay. And then right now I'm just trying to debug where I failed. If I do the cheap hash, which I think I can live with, I had some other failure mode I was hitting. And maybe it's just a stupid bug on my part and I could sort it out and it'll work. I'm looking at my fancy pieces of paper with colored lines and edges and cycles everywhere.
Mhm.
All right. Somebody says something in chat. Um, yes, incremental type checking, yeah, exactly. No, Matt, you're spot on. This is effectively what I'm trying to do here.
There's been this paper at the workshop on implementation of type systems at Popple this year, and someone was actually working at a pretty ambitious project to have like a total static analysis that is done incrementally,
Right.
where you can change some part of the program and you do not want to recompute the entire typing derivation for the program. You just want to minimize what you are recomputing. Because maybe you have like some deeply nested, control flow, and somewhere in there you have a function call, and then you change the result of the function from int to bool. And how do you propagate this efficiently without recomputing the entire program, which would be just way too slow? And of course, for that, you also have to implement efficient comparison
Yep.
so that you don't, so you know what's changed,
Right.
what hasn't. And that's kind of the problem they are solving.
Right.
So
Without cycles, I have my efficient comparison done
yeah, and I
really
also,
cheap.
they called it, the problem was exactly one of the problems mentioned. Either it was this talk or another incremental talk that they said that the problem is that it's not a tree, it's a graph. And graphs can have cycles and yada yada yada. So I
Exactly
would
what
look
I'm hitting.
into
Yes, there's a graph. It has cycles.
yeah, I would look into incremental compilation literature because it's someone might have already encountered some similar problem.
Well, throw it in the doc here, and I'll read it in my copious spare time.
Yeah, and the only thing is that I would actually look at the talk because it's a workshop, so
Hmm.
it's usually not work that is like complete, but something that is still a research in progress. And I think that the talk goes into more detail than the abstract. Abstract is like 2 pages PDF, so it's pretty short.
Yeah, okay. So you asked Theodore what I was doing for simple this week. This is what I've been doing.
Mhm. Nice.
I stalled out here. And then I went along and I said, at one point I wanted non-blocking hash map long. I wanted hash map with a long key. And so I restructured. It gave me one too many utils, so I put a util directory, and that changed everyone's imports for the util. So I changed 250 files to have imports move down a notch, and got rid of a bunch of extra imports and tidied up the import things. So I have, giant stupid diffs that mean nothing except a little cleanup here and there.
Mhm.
Um, yeah,
Mhm.
and then I'm doing mid job hunt, so I'm getting all kind of interviews and talking to all kinds of folks about stuff. That's ongoing as well. Um, well, I'm inspired to think that I'm not totally on the wrong path here now. So I guess
Mhm.
I will sort my bugs out and see if I can get this thing working.
Yeah, cool.
Yeah. Anyone, let's claim that we can be done with this, although I'm happy to carry on even more.
I actually was just today discussing with my brother on a slightly related topic. Um, my brother is a big fan of, or has for years and years been interested in these things called De Bruijn sequences.
Yeah.
Um, and
The
I was
brown,
telling,
it's almost like the English word brown, the brown.
okay, the brown,
Not Bruin.
I'm not getting this right
the
either, to
Bruin.
be honest.
I was pronouncing it De Bruin.
Maybe I'd go with Bruin.
This may
Yeah.
be better.
But anyway, so I was telling him about shape, JavaScript shape, object shape optimizations, and he thought, well, how about you like, why wouldn't you use like these De Bruijn sequences to actually unify more object shapes? And I, and I started thinking about that, and it actually sounds a little interesting. I wonder if if there are any engines, JavaScript or otherwise. I guess in Java you have, do
I
you
mean,
give guarantees of the object or the field order in memory?
that almost surely not. No one can tell.
Okay,
The
so
AA type system will totally unify objects with same field names and same field types,
yeah,
including all cycles and things.
yeah.
But he
So
also,
if you have like X, Y, Z and they are in different orders, you can still
oh yeah, totally.
unify them.
Yeah.
Yeah.
But also, if I
In
have A points to B, points to C, points to A, and I give you a BCA, and the A's and B's and C's have the correct extra other fields, they'll all unify. So cycles work
yeah,
fine too. Arbitrary, complicated cycles work fine.
yeah. In
Which,
JavaScript, there is the problem that you can see the order of the fields by just iterating the object. It will actually give it to you in the order of definition.
yeah, yeah. There is
Uh,
some order of definition that's preserved, not this. I heard you say layout memory, but there's an order of definition. Yeah, fine.
yeah.
Yeah.
So that like usually, I guess engines, JavaScript engines at least don't, I believe, like unless you go to a hash map object, they will actually keep the order of definition. Um, but that then means that your XYZ and XZY objects are different. But then if you have this like easy to manage permutation handling somewhere, maybe using the Bruin sequences or something else. And that could be interesting. Kind of
They are ordered.
slightly related.
They are ordered by types. There's an ordering by type within
And
a
ask for
within a
JavaScript
class for Java.
for Java.
Yeah.
Oh no, if I go to field ordering in Java, don't I get declaration order? You're saying
No, no, it's ordered by type.
I don't believe that, but
Yeah,
maybe I'm.
I went through this once
No.
a while back, and yeah, the fields are ordered by type. And then after, but I don't know if you have like 3 ints, how that's actually ordered. I don't know if it's ordered in because things get ripped apart and so I don't know if it maintains order that way.
Oh, I see. So the Stack Overflow from no, quite old Stack Overflow, so maybe no good. Says, random. I know it went from random to fixed at some point. Because random meant that it was 99% the same except you changed JVM version numbers and then it was different and somebody broke on the version number of the JVM change. All right, so this is too old of an answer. Let me find a newer answer.
Yeah, it was a while ago, so I don't know if they've done anything, but it had to do with how they were packing also.
Right. But I thought that there's a layout where it totally depends on packing. Um, but then I don't know. I thought there was like alpha sorting on field names to get around the random caused rare breakage.
No, the field names just are hashed into a string table.
Right. The field names originally were hashed, so you
But
got.
they just like if you just like um do a more on a class file, you can actually see the structure.
But when I ask for via reflection fields in order, I believe you get a fixed known order now that you didn't used to. Hang on. Let me just go to Java doc here, see if I get an answer that's different now. I thought it was, they said random. The implementation was I walked a hash table of string names. So it was always the same order if the field names were hashed the same, except that under different implementations of hashing and whatever, they changed rarely. But when it changed, everyone broke because no one was expecting this to change because apparently it looked always the same. Uh,
I don't think you can guarantee order. It doesn't guarantee order, but there is an
I
order.
hear you, and I want to say that it didn't, and now it does, and I'm trying to get the actual reflection docs up. Of course, I have a million things here. I'm looking for the get all fields from class, and then he's going to say random, but he might say alpha. Um, get declared fields. Okay, finally got it. No, the documentation says not in any particular order still. Okay, I thought it was going to be given to you in a particular order these days, and he says no.
Yeah, and whether it does or doesn't is simply a fact that they don't want to guarantee any particular order for
Yeah.
to maintain flexibility.
Okay, wait. I did it for Java Doc 8 because that's my default. Hit a button, go to Java Docs. Let me go to 21.
Why not sorted?
Right, exactly. Well, because you're not supposed to depend, but of course you do. So, what the hell? I won't be too long finding it now. Get all fields. I want the class and get fields. They don't make this easy to search for, that's for sure. Here's the doc. Nope. Java doc 21 elements in the returned array are not sorted and not in any particular order. Wow. I would have thought, I swear I saw it come around as I thought it was done. You got alpha, just a
Yeah.
dodged issue. I know
Well,
I have sorted them to avoid this very issue of random.
I kind of think that that you're going to get an order, but the Java docs is going to say there is no order, but
Right.
there will be an order. It's just they don't want to be pinned to
Yeah.
providing a particular order.
I was trying to say that the order was apparently fixed, but not really, and has changed, and that change broke people.
Sure. Yeah, and that's what exactly why the doc says you're not getting a
Not
guaranteed
getting
order.
order. No, but I thought they were fixing it so you wouldn't get broken. Like you depend on it coming in some particular order for one stupid reason or another, and then the order changes at the release between,
Yeah,
17 and 21. Suddenly your program breaks because
yeah.
whatever.
I think that's what I was trying to say is that they want the flexibility of being able to
Still say no ordering.
yeah,
Fine.
just say so the docs are going to say no particular order, but if I test on 8, I bet you there is an order.
Yeah.
And if you go to 17, there's still an order and it might be different.
I'm about to.
And
I'm
so if
wondering
you're
if
dependent
so.
upon an order, then what the Java doc is telling you is like, don't do that because,
Yeah.
we're going to arbitrarily change this at some point in the future.
Yeah. All right. Death by reflection.
Yeah, so like, I mean, the best thing you do is to whip out a piece of code and just play with variable ordering, and you'll probably see the difference.
How would you actually, what would be your like go-to ordering for Java struct field
Either declaration
names?
or alphabetical.
Yeah.
Declaration's probably reasonable. But yeah, one of those two. That would be yeah. And then I totally get where you walked a hash table. Okay, you did. Fine.
Yeah, then that would be dependent upon the hash function, right?
Yeah.
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 And if the hash function changes, which it did because they went right from linked list to AVL or some form of AVL.
Right. Oh yeah, there's that too. Right. They did. Yeah, I remember that.
So, so that would change the ordering necessarily.
All right.
Here's a still continuing on that. Here's a kind of a maybe dumb idea. So say you intern all of your strings in the whole wide engine, at least all strings that go into struct keys. And then you use the string address as the ordering key. Now,
Some feature of the string that's been interned. I wouldn't necessarily say the address, but fine.
well, like
Whatever.
there's a point I'm getting to
Oh,
here,
okay.
which is that now if you use the pointer address or whatever is the address for you as the orderer, um, or as the order of fields, now when you go looking for a particular key in a struct that you've never seen before, if this is ever a thing. I guess in Java this maybe isn't.
It's
In
not.
JavaScript it definitely is.
Yeah.
Then you could actually do a binary search for the location.
I see. Okay. No, the only time you do that in Java is with reflection, where you've already said, and please make me slow. The slower, the better. And then eventually it probably does a hash because the hash table lookup's fast after you subtracted off the enormous overheads to call reflection in the first place.
Yeah, I'm just not sure why you'd want to do that.
Look up a field via reflection in
Well, I
Java.
mean, yeah, I mean,
I so H2O, I'm building serializers. None of the classes are pre-declared as being going to go over the wire to other members of the cluster. So the first time a class gets sent over the wire, there's a handshake made with a leader in the node partition, whatever, leader in the cluster with how we're
so
going to serialize, which lists all the fields that are going to be passed over the wire and what
so
layout.
that's the object field stream, which gets embedded into the class.
In H2O, we built an external class
Yeah,
that wouldn't
you wouldn't
serialize.
have to do that. You could extract out the object field stream from the class itself,
Yeah, I think we're
right?
missing.
And the object field stream will give you the definition you need for serialization.
I think we're missing here. We did a hell of a lot of compression and optimization on the objects we're passing over the wire because they were typically full
Yeah.
of giant arrays with highly repetitive nulls because no portions of those arrays were filled in as
Yeah, I mean, you could do the compression as a second pass, right? There's nothing to say that you have to.
no. The end goal was to say go to direct byte buffer and copy from Java object mutating for the
Yeah,
compression and stuff
right.
into a direct byte buffer
So
in one shot.
so you could yeah, so you can
Disperse.
still basically extend serialization. You're still going to get the object field stream that you could use to do
Okay.
that, right? I mean,
Not a thing when I was doing H2O.
that's what externalize is. It's just a
Yeah.
an extension of
Okay.
serializable, right? So
I claim that if I had touched that, it would have been vastly slower than what I ended up with. But that's
um, um
I was as fast as the fastest published results from any serialization protocol, except I didn't need any marker interfaces or anything. Just hand me
yeah,
an
it's
object, serialize, pass the other dude, unserialized, don't care.
yeah.
And it was, like I said, it was full memory, full network bandwidth, full memory bandwidth. I could drive the hardware to its limits.
Well,
That was part of what H2O was for speed.
without getting into hmm, a
I
mine is faster than yours argument, I would still suggest that you can use information that's embedded in the class itself, just pull it out and just use
well,
it in your
well,
custom serialization rather than
right.
keeping it. But
But
if you did it that way and it worked,
I
good on
pulled
you. It just
out
seems
from the
like extra
class
work.
the list of fields.
Yeah, well, that's what it does. It keeps the list of fields that you
Yeah.
need for serialization.
And
So,
I used those to write a custom class object that had Java bytecodes that just peeked and poked Java objects directly.
right, exactly like externalization, externalizable does.
Okay. And
Yeah,
then compressed as you
which
went.
is really fast. I did some benching on this just to show people the benefits of externalizing the serialization process and
I think
not
it's
having
gotten
it
better
done
over the
internally.
years.
Sorry?
Maybe it's gotten better over the years.
Well, no, serialization still sucks. There's no doubt about it.
Oh, okay. Well, but I thought you said external, whatever. You had another word,
Well,
externalization.
externalization sort of it does it's backwards inheritance. It's like it's like a denial of inheritance, right? Is what you end up doing in that case. So it's kind of like a bad design thing, but give that as it may, you can at that point probably externalize that behavior into some sort of compression algorithm.
Oh, I see. No, I had the useful benefit that when I serialized, it was always deserialized by a partner in the cluster, and we all agreed at the time of first observation of the object what the protocol we would be using for how to compress and decompress, and
Yeah,
then
that's fine.
but no one
That
else,
would still
whatever,
work.
saw it.
But that would still work. That's just
Yeah, no, but I'm saying I have no backwards compatibility. It's like you bring up a fresh cluster, you've changed all the layout of the foo object, you've changed extra fields or whatever. New cluster, new foo object. This foo object serializes this way and deserializes on the other side of the cluster this
okay.
way.
So you managed versioning in the protocol at the same time.
Yes, and version, but the trivial way. New
Right.
cluster, new version.
Yeah. Yeah. Yeah, I could see that you'd want to handle if you wanted to handle versioning.
Yeah, well,
Um,
like I said, it is this
but
is the no effort versioning. The no version of the compressed objects hit disk or hit any permanent storage. It just was to transfer from memory to memory across the cluster.
yeah, sure. But like if you say you're handling versioning, then that's like a completely different problem, right?
I'm saying I am handling versions because each cluster produced its own version.
Mm.
When I said I have a cluster, I meant it's a collection of nodes that we all agree that we're in a cluster. Then we all agree on what our versioning, what our protocols for serialization look like. And then that cluster gets shot down and a new cluster starts up. We have a new version. That was the, that dodged the history versioning thing, which which serialization has to deal with, and I did not, so I got to.
Well, it doesn't basically it deals with versioning by failing and saying
Yeah.
I don't have a definition
Okay. Right.
to map this data back into that thing, right?
Right. Right. Yeah.
So it's so if I foo one and I tried to serialize foo two or
Right. Yeah.
deserialize foo two into it, it just
Yeah.
throws an exception and says you can't do that.
Yeah. I didn't have
Right.
to deal with that one,
So
but yes.
yeah, but even so, it's like what do you do with the missing fields, or what do you do with data where there is no field to put it into?
That's what I'm saying. I didn't have to deal. You brought a cluster up. Every member of the cluster agreed on what a foo object looked like.
Okay, so what did you do with oh, so you just basically said you passed around class definitions to everybody, saying this is
Yeah,
what
yeah.
this thing looks
When
like
the
now.
cluster comes up, we all did
Mm.
a handshake on our jar files, our class
And
files.
so,
And if they
so
were
all of your
disagreed, we blew the cluster up and said, "You guys got incompatible jar files." No.
okay, so these definitions were ephemeral then.
Yeah, yes. That's what I'm trying to say all along. They're just with the cluster.
Yeah, sure.
Cluster up, cluster down, new definition on cluster up. Fine. Which gets you some nice shortcuts. You don't have to deal with versioning. That's what I'm saying. Is no dealing with versioning.
Yeah, it sounds like a cluster.
Clusterfuck works
Yeah,
great for our use case.
yeah. Yeah. Okay.
All right, enough with enough with serialization.
Yeah.
Reflection, what we're here for. Field ordering. Why do we get here? Because we had cyclic types and JavaScript. Was there anything left untouched over that front? Apu was like, yes, no, yes, no. All right, kill
I,
things
I'm
here.
seeing if anyone else, comes along.
I'm running around with the thing. I don't have I don't have your JavaScript friendly version, but I have the algorithms that I can step you through if you care to allow discovery of cyclic related types that we all agree on the field names and field types. Um, but it's more or less DFA minimization algorithm. with extensions to deal with fields and edge labels stuff. There's a few extensions to DFA minimization and a lot of hacks to make it go efficient. I mostly don't need AA mostly doesn't use DFA minimization if you're recursive descent. But if you actually get cycles and the cycles are known to be, there's another property they have to fail on, and then I have to go to DFA minimization. Fine. And that's the one I didn't want to do for simple. Okay. What else?
Oh, I have a topic.
Uh-oh.
Let's say you have an optimizing compiler. You beat your competition, but you want to improve it further. So what we used to do, we used to look at competition. We used to analyze benchmarks where we have gaps, like see what we're missing. We basically ran out of them, or at least ran out of easy ones. So the question is, how do we find new optimizations?
You
Okay, we
gotta
can
have
stare we
there's
can
no
stare at benchmarks and like stare at hotspots and just invent stuff.
well,
But I'm looking, is there something more methodical other than just okay, look at benchmarks and like figure.
yeah. Yeah. You go check the large corpus. Like don't make optimizations blind. That's no good. No one knows, no one cares, no one can tell. Go grab a larger corpus and get a larger benchmark suite. And then now you have something to drive against.
Can I answer this?
Say what?
Can I answer this?
Yeah.
Yeah.
I'm going to use more childlike words in my answer than what you would,
Uh-oh.
if that's okay. I mean, in the organization we're in, what we envisioned doing was being able to go out and talk to actual real live customers and do analysis on their applications and find the things that we can commonly see happening and basically go off and see if we could correct those. So an example of that is we found that there are many, many improvements that we could actually do to escape analysis to get much, much better, like uh, scalar replacement. And in some places we were looking at it saying, okay, so what are the things that are commonly showing up in applications across a whole set of live applications, so we had access to, large customers with very large code bases. And in those cases, we just said, okay, let's sit down and direct the optimizing compilers to try to get a better job of these, like scalar replacement happening in these particular cases, because we could see that, this was like a common bottleneck across many, many different applications. So in this case, there was a direct benefit to, a large set of applications for
Right.
this particular optimization. But that only really come about from deep analysis of what, a body of their applications were actually doing.
It's like 5% on every app as opposed to 2x on things that do HPC computing.
Yeah, there is a common theme of look at large corpus of programs and find commonalities.
I suspect that escape analysis would be fruitful for you.
Nowadays could probably just troll all of GitHub and pick up, say, the 1,000 most popular projects in your language. Another
But
thing is,
you want them to be able to run and execute so you can get,
Yeah,
is there a corpus of these GitHub things that you have?
look for the ones with the working test suites at least. Of course, the problem, do not use the test suites themselves because test suites will exercise the most exotic code paths in those applications, so you
Right.
may end up optimizing what you should be pessimizing.
Yes, right.
right.
Yeah.
So here's the problem with that particular approach is like, let's just go look at code in GitHub. That's not what I'm looking for. I'm
Yeah.
not looking for code. I'm looking for um, patterns of hardware usage that I know are problematic. And I'm only going to see that in live applications.
So you're talking context switches as well as like allocation rate and things like that.
I don't really care what it is. I'm looking for patterns that I know are problematic. And then at that point, we want to look at, which one of these patterns can we quest by making changes in 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 the underlying optimizing engines, right? And in our particular case, in one place we went after, we found that optional is a real problem,
Yeah.
a real serious problem. So, it's like,
Don't use
why
optional.
is optimal not being OSR? It's a very, very, very small allocation. Why is it failing escape analysis? Let's look at root cause, see what we can do to improve the path down there so that, we can avoid having all these optionals basically being allocated on stack, right? So that's one particular example. I mean, and there were other things that were,
Yeah. The answer,
that
of
that
course,
that
is
showed up.
don't use optional. Fine.
So
Yeah, tell that to Brian Getz.
Yes, I will.
No,
I
but
know.
I think
Good
that's
luck
an
with
Yeah.
that.
example that's an example that you would find with this GitHub strategy as not usually find runnable applications when you
No,
look
you
at
wouldn't
those
actually find
popular
that in
codes.
The GitHub strategy. I would
uh,
disagree.
qu-
You will not
qu-
find that in the GitHub strategy
We need
because it's
question
not
to
visible.
question to Kirk. So you say that you're looking for problematic patterns, but how do you do this? Are you looking for these patterns in the assembly? Like, are you looking at the profiles? Are you looking
Right.
at like doing some kind of aggregation? Like what?
So so I'm looking for bottlenecks in the code, and so what I'm trying. So the problem with when you're looking for like when as soon as you say bottlenecks, you have a problem because you were looking for a bottleneck for a given modality. And the problem with test environments is that you generally only you generally test in modalities that you don't see in production systems. And so if you look at a large body of applications that are running in something approximating a steady state in some modality, then you're generally going to find that this is a bottleneck in the system. Now, in that case, I'm not looking at code, I'm looking at hardware. And I'm looking at the patterns in the hardware, patterns in how the hardware is being used to basically identify what is the constraint within the system. And now I want to use that to infer what the application has to be doing in order to get the hardware into that particular state, and then I'll profile back to characterize that. Once we find that, then I'll look and see is that a pattern? Is that something that we can actually see across multiple applications? And if you can see it across a wide range of applications, then that's probably something that's going to be beneficial to a population of users. And those are the things that you want to go after in
My
general.
question is, how do you get this sample of the large range of applications running in production code? Of course, if you have customers that can share that, then that's no problem. But assuming you have already run out of those customer benchmarks for some reason, you do have to spin up your own benchmarking then, right?
Well, no, like I said, wouldn't use benchmarking for this because benchmarking is artificial because it's probably going to put the application into some exotic modality that's not
So
going to
only customer
expose.
workloads is what you were saying, and you would only collaborate with customers giving you their production data.
Absolutely.
Okay. Yeah, of course, that's ideal because then you also have very clear economic motivation to fix those bugs.
Right. And you need to have someone who actually knows how to find bottlenecks in the system. And I find that that is unfortunately a rare skill because most people will now start looking at applications, and that's probably the worst place to start.
And then for the hardware, you mean you start with like basic hardware counters,
Correct.
see where things are. Mhm.
Correct. Yeah. I mean, you can typically with many applications, what we want to do is like weight state profiling.
Say again?
You want to do weight state profiling. So I don't really care what the CPU is doing. I care about what the CPU is not
Not
doing.
doing. But you're actually mapping that back to something the application's doing. This isn't like I'm stuck waiting for a DB call. This is like I'm taking endless cache misses.
Exactly.
Mhm.
So and I know the allocation thing will turn into endless cache misses, but are you getting this from other angles as well?
Well, generally, if you don't know what you're looking for to start, you need to be somewhat systematic in how you tackle the problem, right? Which is, why I have, my prescription to the problem, which is just you know, obviously not the only way to do it, but it gives people a data-driven approach to finding bottlenecks in the system, which is problem, starting point and a process, which is better than what most people use today.
But
And
in this process, at some point, I'm going to say you're visiting, blocking because of an external await event. I went to
well,
went to database disk.
yeah, okay. I mean, so I look at it this way, right? If you look at the definition of noise in a system, noise is I've had to do something where I need to compete with something else and I'm getting external interference, right? So if I'm able to keep a process in a core and I don't have to ever wait for anything, so I don't have to go off chip, then that's ideal. As soon as I have to go off chip, then now I have to compete with other things that are happening there in order to get the resources I need in order to get the information back in order to do the calculation. That's noise, and that creates variability, and that creates wait states, and that's where a lot of your waste comes in. So what we're looking for is situations where you can avoid that to basically keep the processing on the chip as much as possible, so I don't have to go out and compete with other processes
But doesn't
for
have that
buses and things like that.
doesn't that have always depend on things? How long you will be scheduled on a chip on the processor?
Yeah, I mean, of course. I mean, there's a lot of variability in it, and you're never going to get it perfect. But the whole
Mm,
point is that if I look at, there's certain things that show up that are obvious, and those are the things,
mm,
if you can make impact on them, those are the things you want to go after,
mm.
right?
Yeah.
And really, that really means that if the larger the population of applications that you have, the more you can see if this is a general problem across a population of applications, or is this just specific to one application?
So
And
I'm hearing Arthur say he's looking for something that he could tackle, which would be at the code generation level, escape analysis, as opposed to at the systems level, which maybe, push the whatever the
But the
push the
optional,
DB
I have to
together.
admit, the optional thing still slightly surprises me that you couldn't find it. Maybe it's where I'm coming from. Say, I'm coming from C++, so what I would expect to find is I run benchmarks on Chrome, and they are benchmarks that are basically browser benchmarks. So I have one way to benchmark Chrome application. And then I run compile benchmarks on Clang LLVM, which is a C++ application itself. They both use stud optional, which is a little bit like Java's optional. I would expect if this is a common bottleneck, then I would find this across large C++ application running
yeah,
benchmarks.
you would, except for most of the execution profilers will not expose it. They will actually hide it. And so if you go through all of the profilers out there and you basically look at all of their biases, you're going to find that, and especially on how it's reported, right? Because one thing is like, this is a time for optional, it's a time to first byte problem.
Mhm.
Everybody reports on volume. They don't report, they infrequently report on frequency, right? If they report on frequency, then in the case of Java, then you basically get interference with the JIT compilers, which means that you don't get to see the optimizations anyways, which means you have to do a separate study where you just look at JIT compiler optimizations so you can have some tool to basically minimize the bias in the data or account for the bias in the data that you're getting from the profiler. So a lot of these problems, like if you use just some of the standard profiling techniques out there, you're simply not going to see them. Like, anybody that does like T-lab sampling, you're not going to see it. There's a order of factor of about 300% fewer events being recorded by the profiler for optional than for, say, a normal size Java object.
So
Right.
I think you can definitely write a dedicated micro benchmarks that shows a missed optimization opportunity.
Yeah,
What
you can, but does that apply to something that you see in a broad range of
Yeah,
applications?
what it doesn't tell you is how like how frequent this thing is in real life.
Yeah.
And
So there's a Bill Pugh strategy which says run the app, get your app running and it runs, then go into the optional code generation and force it to take twice as long. Like in your Falcon come through and say, oh, it's another optional and we couldn't get rid of it. So instead of having do the default thing, do the default thing plus X again,
Mhm.
and then measure the application time again to get an idea of what it means to double optional.
Yeah, one thing that we have for
That would
this kind
work.
of analysis, how frequent some patterns are, we have a whole bunch of pattern matches of we call missed optimizations or no, known optimization opportunities. And before, like we have an idea, okay, I can do this kind of thing. If I can write this pattern matcher before I actually implement the optimization, I can count how often it fires in, like, I don't know, in real applications that I have. And if I see it fires like 5 times in everything that we track, well, probably I won't bother. But if I see it fires on every other compilation, sure, I'll go and implement it.
So this is you doing some sort of pattern. What I often found, I don't know, maybe it's just different here, was that the effort to discover a valid pattern match in order to do something was 90% of the work.
Yep. I would
Uh,
agree with that. I would
it
absolutely agree with that.
it depends how precise you want to be. If you only want to estimate like how often something shows up, you can estimate the upper bound. You don't need to estimate the exact like you don't
You're
need
saying, yeah, don't be precise on
yeah
the just guess.
Mhm.
Hey, it
yeah.
seems like
If
there's a lot of these. Yeah.
If my upper bound, some pattern matching that doesn't account for some of the correctness validity conditions is still low, well, it will only get lower with more correct, with more accurate pattern match.
Yeah. If
I'm not one to base it when you come to performance analysis. I'm not one to say that you need to know everything that's happening down to the, last significant digit. You know, this is a term I use. Let's say, swimming pool chemistry applies here, right? Uh,
fine.
so if you're in the ballpark, you're good enough. That's all you need to know. It's like, are my measures driving the behavior that I want, right? Rather than are they precise? And I would say, and I have to agree with Cliff, is like do I put 2 scoops in the pool or 3 scoops in the pool? Is getting to that level is going to be most of the work. 90%, 80%, we can argue 70%, we can argue about that, but I'm still going to say it's most.
So okay, this yeah, this idea is we look at real applications, we see what we don't like, we see what generalizes across multiple applications.
Yeah.
Comparing
And
Falcon
make
to
sure it doesn't
C2,
cause regressions.
comparing Falcon to C2 is a way to find obvious holes, but comparing Falcon to wall clock time is the next thing to go do. How
Hmm.
to make this faster, not how to make it faster than X.
Yeah, I wouldn't care about how to make it faster than X. It's just how to make it faster is the issue, right?
Yeah.
So
All
wall
right.
Okay,
clock
and that
is
one is
ahead.
harder. Like when you have some other implementation that can show you gaps in your like
Right. So if you've run out of gaps, it's time to move to the what can we do now? And
Yeah,
that's what Kirk
I've
said.
I've never seen anyone run out of gaps.
No, but you run out of big gaps. You
yeah,
do.
you run out of easy ones.
Yeah.
Like you have few annoying ones that are really hard to solve.
Oh,
It's like
oh,
No,
oh,
he's talking about gaps against a competitor as opposed to how can we speed up this app in general? A large, big, complicated app has a bajillion optionals. And
It
C2's
is,
not doing anything with them, and Falcon's not doing anything with them, and they both kind of suck. What's the fastest way, or what's the most gain you can get out of this big app? Maybe it's to go beat on optional, even if the competition's not beating on optional. You don't care what
yeah.
C2 does. You
Well,
know, kind of make this faster.
we just had this guy come to us. He's like testing ARM chips and AMD chips and Intel chips, Java 17, JDK 21. And he's going like, well, 21 on ARM runs slower than everything else. And he's going like, why are these ones running faster and why are these ones running slower? And I'm going like, I don't really care why those ones are running faster. I just want to, what I do care about is making this slow one run faster. So what's the bottleneck in there? So rather than running like a whole array of benchmarks, giving me information that I don't care about, I just focus on the slow one and characterize it and try to get an understanding of like what's going on there, either at the chip level or in the code that's causing the grief.
But you have an invariant, you have your code and you're moving across different architectures that would reveal some design decisions that you can optimize for a particular chip.
Yeah, no, I don't really care. I just want to know why it's going slow on that chip.
Hmm.
The rest of it to me is noise and a distraction from the ultimate goal of making sure the implementation on the ARM chip runs as fast. I mean, we have a set of numbers, so we have a benchmark produced by running it across all the chips. For me, that's good enough. Now
No.
all I need to do
I,
is make sure that everybody's equal at a minimum.
Yeah, that was I said. You have an invariant that you're moving, so that would reveal why that
No,
some chip is slower. That some,
it'll reveal what you need to do and which ones you need to level set or make
yeah,
faster. But once you
yeah, yeah,
know which one you need to make faster, just focus on making that faster.
yes, yeah, agree.
You know, if asking why something runs fast is, I don't know. I I wasn't sure if that's
no,
productive.
there's but gains both way. One is
Yeah.
somebody figured out something cool. That's the versus C2. C2 did this really quick and we didn't. What happened? What did C2 do? He did a cool thing. Go look at that one. Very specific, very targeted. Once you're past that point though, then you're right. Then I think you're spot on with the other
Well,
direction.
I think you need to know like, what is the bottleneck that's keeping this one
Yeah.
slow? And
Yeah.
then you might be able to go back and say, okay, how are these other ones handling that condition?
Yes.
That's a
Yes.
completely different, that's
It's
a
different.
completely
Yeah.
different way of doing it,
Yeah.
right?
Yeah.
Um,
And I wasn't saying anything counter to that. It's just if you're
yeah.
generically trying to speed up the universe, if you can't beat C2 or at least tie C2, maybe you're missing something easy. But now that you're tying C2 everywhere and beating in some places, can we go speed up more and then quit asking C2 now? It's not helping. Go ask the app in question. What can we do?
Well,
Why are you
I
faster?
still think C2 is setting a bench.
It
It's,
is, and,
it's
you
setting your
know,
bench, right? And
it's
so,
an obvious, easy target to shoot at. You have to be able to
exactly,
you have to be
exactly.
able to get close enough.
So,
Yeah, but I think it's, sorry, Arthur.
yeah, another way to look at this problem, one of the slicings for this, let's say you have a fixed program, like you have a benchmark, and there is a question whether it's hypothetically possible to do better job for this benchmark, or you are like literally running into the like limitations of your CPU. Like I don't know, if after stripping away all the abstraction layers, all you do is just moving memory from one buffer to another, probably no more compiler optimization opportunities left.
Mm.
It
And
could be.
how to determine this without studying every single piece of code, every single benchmark?
Find the
Like,
bottleneck. There's
I
like
yeah,
this is the garden hose problem, right? There's always a downstream until your CPU is your CPI and your CPU is like maxed out. Right? You're always going to find ways of getting it closer to the max. And if it happens to be maxed out, then just start figuring out ways of reducing the instruction counts.
Or
I'm
maybe allocations, or maybe caching.
I think I maybe have a more straightforward answer, which was I just did statistical sampling of the corpus. Arthur, you're like, I can't make this one go any faster. Okay, you can't. Maybe you
Yeah,
can't.
there's
Maybe
always a
you
way.
can, but well, no. There are things that you're just not going to go faster. If you're going to compute terasort and you hit the memory bandwidth limits, you're done unless you make the sort smaller. But at the level of a compiler, you're not making the sort smaller. right? So at some point, the compiler hits its limits and you have to widen
Yeah.
the scope. And in my case, I'm suggesting widen the scope by picking a different application to go speed up. And you're commonly saying I have an application, but it's not just the CPU, it's all these other parts all mixed up together. And you're trying to take a broader view of how you speed up. And Arthur's going to be coming in at the what can we do at the cogen level?
Yeah. So
Yeah.
I agree that yeah we'll look at one and see that an opportunities go to some other place. But I think so far the best idea how to do this is to stare it and analyze. And it's a very labor intensive work.
I did a
Yeah.
lot of that.
So I'm looking like is there something I like the idea of looking at the CPI because it is kind of a metric that can tell you how far you are from the limits of the from the underlying CPU. But I'm curious if there are,
Include memory bandwidth because CPI, if you're just out of memory bandwidth, you're out of memory bandwidth, and that's what you want to reduce.
yeah, that's a
Because
good
Yeah,
like
but
CPI is
idea.
that's
not the
going to
only metrics here.
but that's going to influence CPI.
It is. No, it totally is. He gets a
That's going
number,
to so
CPI says it's not great. If
well,
it's
okay,
out of
but
memory
okay.
bandwidth, that's an entirely different.
Oh, okay. So this is the other thing I try to get people to do. Is I try to get people to do this like stepwise, right? Not you don't want to eat the old whole elephant in one shot. And in this case, the CPI is an indicator of an issue, right? The issue might be you're out of memory bandwidth. But I'm not gonna go from trying to collect all metrics across the entire machine unless I can do that really cheaply. I'm just going to collect my indicators, use the indicators to infer what's going on, and then collect the metrics that are related to my inference. So that's why I suggest using some form of a classifier on a base set of metrics in order to help you understand where you need to go next in terms of having a more targeted um, uh, why performance is what's that?
I think Apo
Yeah,
dumped this
sure.
out. It looked entertaining at least, so I was throwing it up and taking
So
pictures.
performance optimization is hard work. I'm going to claim that since I've been able to do it successfully over a number of years, that it's not hard work because everybody in this room is infinitely smarter than I am.
Well,
So
I think
actually
we
I like
can agree that we're running this topic. This topic feels mined out here. I think we're kind of
Yeah, I think
going
so.
around the same stuff.
Yeah, absolutely.
yeah I like the idea of running classifier on the set of metrics. Um,
And that's what we did. And we had this actually running in production systems. So we're pulling out um, well, we used AI, machine learning to populate a random forest and for a decision tree or type thing to basically try to understand, what class of problem that you were in, and from there we could apply recipes in order to fully characterize. Just recently, we took those the output from those recipes, fed it into Copilot, had it change the code, and then redeploy. So we had like an end-to-end detection to repair, all at machine scale, right? I don't think
do
you're going to do
you
that for these types of problems. These are for the simpler sets of problems that you're going to find in typical production systems, but it did show some interesting possibility, and it did show that if you're data driven on each step and you approach it stepwise, sort of methodically, that you can get to conclusions in fairly predictable timeframes. Yeah, the solutions might um, be the idea is to make the diagnosis kind of trivial and sort of flip I spend most of my time diagnosing and very little of it repairing to basically having the repair problem become the more difficult aspect of it. Compilers are smarter than humans.
Yeah.
Uh,
There is this paper from Ahmed Yassin, who is this inventor of the top-down performance methodology at Intel for the microarchitecture counters, and he basically looked at the matrix of the what you are bound by category. Are you bound by the front end? Are you bound by the back end? And if you are bound by the back end, is it the memory or is it something else? Is it computation? So collecting those performance metrics, I mean, usually you will just tell you whether you are bound by the compute or by memory, and then you can see what kind of compute, what kind of memory, what are you
Well,
waiting for when this instruction doesn't execute.
okay. So I find that type of analysis useful, but that's like parts of the first step. The next step is to infer at a code level and an aggregate code level, what has to happen on the machine in order to get the machine into that state.
But this step already involves some manual analysis, or you have
No,
some.
we've automated all that.
Okay, can you elaborate on that part? How you find the code that brings the machine into that state?
Well, okay, so what we do is we do a categorization so we look at the metrics, and based on the metrics, what we're trying to do is figure out, okay, like what is the pressure on the hardware that's impacting latency? Okay. And from that, we're going to classify it into a couple of different categories, and each of the categories are, not surprising. It has to do with which piece of hardware am I actually putting the pressure on, right? Am I on I/O channels? Am I on, network channels? Am I on memory bandwidth? Am I on, whatever that happens to be? Now that I know which piece of hardware the pressure is on, what we can do very simply from that is just say, okay, in order for you to be having pressure on this part of the hardware, in aggregate, I need to be doing this type of activity. This type of tooling is best for exposing that particular type of problem. And so I'll just use that tooling to further characterize, identify which code is problematic.
Well, let's pick an example. Let's say we run into memory bandwidth limits.
Mhm.
What is the next step?
Um, if you have memory bandwidth limits, then I'm going to do some allocation profiling,
Yeah, I
right?
haven't sped
So
up.
you have to go up, you have to go sort of like bottom up and top down at the same time, right? Because if I have multiple processes on the hardware, what I want to do is I want to find who's contributing to the pressure. And so what I'm going to do is go top down using latency measures to try to sort out or I'll use in this case, some allocation measure, whatever, like some proxy measure of allocation that I can get cheaply. In the case of Java, that's basically, you can get that from garbage collection analysis. You can do that very quickly. And that's going to tell me who is it's going to infer who's the main contributor to the problem, or maybe it's a problem where you have equal contribution. Whatever that picture looks like, that's going to help me target which actual process to go after on the machine.
And is this part also automated, or this is where you like?
No, we've automated that part also. That's pretty easy. Once we have a categorization, knowing which tool to use is just, that's an imperative decision. So we can look up the recipe in a dictionary and just say, do this, boom, right? And then we can do automated analysis of the results. And we're doing different forms of AI to generate a report like that's readable and intelligent. People who are less skilled at this could actually pick up on and read it and understand what next steps should likely be. And the other thing we did recently was take that report and target it and towards an AI engine, which would then, if you fed it the code, would then alter the code accordingly.
Right.
How is this part working?
It's what do you call it? Early
A
days?
work in progress.
A work in progress? Yeah, exactly.
Mhm.
I mean, sometimes it works, sometimes it doesn't. I have one particular problem which does have allocation pressure. It reduced the allocation pressure significantly. I got a 20% in performance improvement on the first iteration with the code generation. It actually went after the right stuff and everything. In that, but I know that there is about 1,000x performance improvement available to me. So the 20% wasn't a lot considering what I know is available. But I figure with a couple of of
Right.
iterations,
We're
it
gonna
it might
wrap
approach.
it up because I'm running out of my time limit. I have things to do.
I'm wrapped up. I'm done.
That's actually interesting. I'm curious to hear like if you join next time to talk more about it.
We can do that next time. Absolutely.
Yeah,
That was
I'll
an
be
open invite
away for
to
the
show
next.
up again.
I'll be away for the next couple of weeks, unfortunately. But yeah, I don't mind coming back to look at it. It's actually the other thing too is we tried to make it as simple as possible so that like I said, the whole idea is to make sure that other people who are
Wrap.
less skilled
I think.
can follow it. That's it. Okay.
Okay.
Sorry.
All right. Anyone else have unrelated final questions, comments, things? I'm going to declare victory for the Alliance here. All right. It was fun. And hope to see people, next week.
All right, bye everyone.
All right. Bye-bye.
Bye.
Okay. Thanks. This is Cliff. Bye.
Yeah. Thank you.